name's Petrus. Today I will talk to you about reducing cooling tower water losses using Arduino Uno Rev 2 via Wi-Fi Internet of Things device. On the first slide over here we have a typical cooling tower system comprising of single cooling towers. On my presentation I'm just going to focus on a single cell. As you can see, this one's got multiple cells. Typically a cooling tower will have a makeup side and a drain side. It will also have a circulation pump and evaporation fan. As the water circulates within the system without diluting it or without taking it out, the dirty water, dissolved solids build up. Over time that causes the makeup valves basically to get stuck open, which leads to water losses. If the system is remotely situated, then you will find more and more chance of having overruns of your water where the system doesn't switch off. This leads obviously to lots of cost depending on your flow rates and the consumption of the rates per kiloliter of your water. The next thing to notice obviously is your drain valve might also be left open manually by operators. So what I've done is I've designed a system, if we look at the second slide, which basically shows you the architecture. So as I said, at the bottom here you have your instrumentation, typically your level switches on the also is used in the cooling tower. Flow meters, conductivities can be added, etc. And then you also have actuator, which is basically your valves open close, and your motor, which is your motors, which is your fan and your pumps. In the middle we have the physical system, and this is the scope of my project. It's purely on the Arduino side, the physical interface, the control system layer, and basically the internet layer. On top of this system, what you could add is a cell phone for visualization, for controls, and receiving alarms via an SMS or other system. All of this via the internet. You could also have reporting system which picks up the data and starts storing it, providing you long-term trends, further emails or analysis information, allowing you to printing it or to backup. Okay, looking at the third slide, the block diagram. Over here what I've designed is basically again the Arduino Uno Rev 2 system with a PC board, which basically is connected to the internet. First and foremost, how we program it is via the serial side of things, the USB, using the IDE programmer. I've used the offline version. There is a scenario where we can also program it remotely for maintenance support through the internet. I haven't tried it on this project as yet. Secondly, I've also added a LCD display which we can use for local information display. That will be the next phase of the project. Looking at the board itself, I will give you some more information, but just looking at the overall block diagram of the components, we also have a cell phone. The cell phone I've used in my case is also my private phone, which is my portable hotspot. So the Arduino is connected to it, and this laptop, which I'm also using then to in future reference a website that I haven't developed but want to develop still, and the app that I can put on the phone, all accessible via the remote side of things. App via MIT, maybe Flask as the developing software for the web server. Then what I have used is I've used the ThinkSpeak, which is an international product or cloud-based, call it portal from MathsWorks, which basically I'm using to display all the data on the internet, which is depicted over here. I'll zoom into that just now. So again, all of these things are via internet. If you go to the fourth slide, there you will see the circuit. Unfortunately, I didn't want to put my Arduino onto a board at this stage, so I had to develop a part of a circuit, so I opted just to add an interface board. In industry, a lot of different which are basically control voltage specific. Then also what I've done is basically I've just shown you the interwiring between the board. I could have bought a board here, but I didn't want to buy a board. I'll show you now on the end result also other board I've made. On the circuit itself, which is this board, you'll see there's a top jumper, there's a top jumper, bottom jumper that I've added, just a normal variable board at this stage, with some resistors and LEDs on it. and the two relays, again for the drain valve and for the makeup valve. Looking at the last two slides, the bottom left one, here we have the flowchart, which basically shows you the software logic. On this software, the most of the software I wrote myself. The only software I've had to reuse or use from the internet relates to the communication on setting up the Wi-Fi on the Arduino, and also on setting up the ThinkSpeak communication channel. Looking at the last slide, this is the photos of the end result. Here you will see the product I've built, the box, which I'll show you just now in physical as well. And also what you'll notice is the inside of the box over here. I'm not sure how much you're seeing on that video. Then basically here I'm showing you the trends, the set point trend you'll see, and then lastly the actual trend, how the system works, and a top lid. Here you will see the system controlled within very small tolerance of the actual set point. And I'll explain the algorithm. If you look at this box in my hand, this is the actual product that I've built. So what it's got a makeup limit switch, or sorry, a level switch on the top right. And then if the level is not healthy, in other words it's low level, this LED would be off. At the moment it's not powered on. It takes a long time to simulate this because it's built for a slower process. Then what you will find is basically this LED will start to light up, the makeup valve will open. At the moment the flow sensor, then I've put it, if it's on top, it will start to increment. As it increments, basically it will get higher and higher and higher onto your set point. As that hits the set point, the valves will then close, the totalizing will stop. If it continues past the set point, the drain valve will switch open, which basically then the light will switch on and the drain will start to totalize. At the end, basically the drain will switch off, the LED will switch off, the totalizing will stop, and at some point again the makeup might start because it's not on set point. So as it makes up, it will make up again, makes it level, the level will come on, this will switch off, and the level will switch off. So basically this whole process, or the IP, sits within the algorithm to control this level. In the options that the client had, looking at the first scenario here again, is they may add a lot of instrumentation at a lot of cost, which basically then I can let's say reduce through my algorithm by just using the standard equipment they already have in place, trying to control what is called the COC, or the cycles of circulation. Thank you for watching. Hope this has been insightful. Thank you.